Okay? So you set something on a surface, the surface pushes back up. Okay? So if you are, if a car is going along a highway, its weight is pushing down on the highway is pushing back up. Okay? So the normal force is always perpendicular to the face of the surface. Now, what if you don't have a surface? What if something is hanging by a thread? Tension force is the force that holds something up. It is the force that is provided by ropes, strings, cables, chains, etc. Okay? So if something is attached to a string, a rope, a chain, cables, that is a tension force that's being provided. Another force that can act on objects is the friction force. Okay? The force due to friction. Now we are going to go in detail in the next chapter about kinetic friction, static friction, and how to calculate frictional forces. But right now we just need to know that it exists, that it is due to a rough surface, and it is always acting parallel to the surface and in the opposite direction of motion. Okay? Now, there are different types of friction. If you are falling and you have air resistance or air drag, that's going to be a type of friction. Okay? We will treat it as friction. Now, the other types of forces, the main one that you have to deal with for this test is going to be applied forces. So F1, F2, etc. Okay, so this is an applied force, a push or a pull. Okay, so those are the main forces that you are going to be dealing with. Okay, now one of the things that you will need to make sure that you know for the test is you will need to know how to draw a free body diagram. Okay? You will not have to draw one, but you will have to the right one. I went to sleep. So free body diagrams. When you draw a free body diagram, if you want.
Okay. We're good.
Yeah, take out the whole stretching part.
Yeah.
Okay, so free body diagrams. You're going to draw the forces acting away from the object. We are going to show the object as a particle, just a dot. Okay? So if you're in equilibrium, should cancel each other out. So they should be equal and opposite. Okay, so if you're in equilibrium, and we're sitting on a surface, we have the force due to gravity. We have a normal force, okay? If I'm being pulled along the surface, I'm going to have a force pulling. If I'm pulling at constant velocity, it means that there must be a friction force acting in an equal and opposite manner against it, okay? So, I am going to give you guys, and those of you that are going to be gone on Wednesday, I will send out pictures of the document with example free body diagrams for different situations. But that's something that we're going to do in class on Wednesday. So, okay, let's look at just a couple calculations, things that you will need to know how to calculate for the test. The first one is you need to be able to calculate simple problems using force is equal to mass times acceleration. So, there are two main problems. One's a level 1 problem, one's a level 2 problem. The level 1 problem, you will be given, so if a 10 kilogram object is accelerated at 3 meters per second squared, what force is applied? Okay, on a calculation like that, we are simply going to use F equals ma, put in the mass, put in our acceleration, and get 30 newtons. The level 2 question would start the same way, and then it would say, if a 10 kilogram object is accelerated at 3 meters per second, if the same force, turn it off, is applied to a 5 kilogram object, what's its acceleration? And in that case, we would use the same force, 30 newtons, we would put in our new mass and solve for acceleration. And we would have an acceleration of 6 meters per second squared. And so you may be given a double situation where you have to solve for the force in the first situation, and then that same force is then used in a second situation. Okay. Another type of problem that you could be given is if you have multiple forces acting on the same object. If you have an object that is experiencing a 10 Newton force to the right, a 20 Newton force to the right, and a 40 Newton force to the left, if it has a mass of 5 kilograms, what is its acceleration? In this case, the sum of forces, Newton's second law, is equal to mass times acceleration. This is where we'll make things positive and negative. So we'll say 20 plus 10, because they're both acting to the right, minus 40 is equal to my mass of 5 times acceleration. So 30 minus 40, so we have minus 10. So my acceleration will will be minus 2 meters per second squared. So you need to be able to sum up one-dimensional forces. I won't give you any two-dimensional, but sum up one-dimensional forces and find the acceleration. Okay?